Alright, let's do the solutions for the homework 2 problems. The first question is to make the project network. Alright, in this problem, what we have is, I usually like to start with a start. Call it start. Right? So we know A is the only one without a predecessor, so you can just go ahead and make A. So A, to get started. B, well, B has one predecessor, that is A. C has one predecessor, that's A. D has one predecessor, that's B. Similarly, E has two predecessors, C and B. G has, well, before Z we have to make F. F has one predecessor, that's E. Then G has two predecessors, D and F. And then H has one predecessor, G. Well, we are done at H. I sometimes like to make a finish. Again, start and finish are really dummy nodes. You can choose to make them, not choose to make them, it's up to you. Alright, let's get started with the second problem. The second problem is slightly bigger, but really nothing difficult again. Same exercise as the first one. Alright, again let's do the same thing. Let's start with start. Again, you really don't have to do that. After start, we have A is the only one without a predecessor, so A. B has one predecessor, that's A. Now there is C, D and E coming out of B, so divided into 3. C has one predecessor, that's B. D has one predecessor, that's B. E has one predecessor, that's B. Well, then C has after E, F. F has one predecessor, that's C. G has one predecessor, that's C. And then E, F, G, H. H has two predecessors, F and G. And then we have I. I has three predecessors, H, D and E. And then we got J, its predecessor is I, and we are done, so we can celebrate with an F node. That's all there is. Alright, let's go to the next problem. The next problem is slightly longer. Well, actually it's long enough that there's no space for me to draw here. Let me go ahead and do this S note here, but create a new one. Alright, in this problem we have slightly more nodes. Again, I like to start with a dummy node start. Again, you don't have to. A is the only one without a predecessor, so A. Start to A. Then B has a predecessor, that's A. C has a predecessor, that's A. I, B, C, D. D has one predecessor, that's C. E has one predecessor, that's B. F has one predecessor, that's C. E, F, G, H. F, G has two predecessors, D and E. G, H. H has one predecessor, that's G. G, H. I has one predecessor, that's H. J has one predecessor, that's F. G, H, I, J. K has two predecessors, I and J. K. L has one predecessor, that's K. M has one predecessor, that's L. N has one predecessor, that's J. O has two predecessors, M and A. Well, we can finish this with a finished node again. That's not necessary, but that'll make it life a little easier in some cases. Alright, let's go back to working on the problems. Question number 4. And this is a nice read for you to understand where PERT fits in. And alright, now in the PERT questions, instead of having one estimate of time, you have multiple estimates. You have A, you have B, and you have M. So which one do you use? Well, the idea is neither, right? What you do is you find an expected value, which is given by, using all these numbers, is given by A plus 4M plus B divided by 6. Okay? If you go ahead and do the thing, A plus 4M plus B divided by 6, for A you will get, so for A, let me do it for 1A, that will be 4 plus 5 times 4 plus 8 divided by 6. So this is 4 plus 20 plus 8 divided by 6, which comes out to be 5.33. Right? So if you go ahead and do that, for A you would get 5.33, for B you would get 7.16, for C you would get 10.66, you would get for D 3.5, for E you would get 6.5, for F 9.5, for Z 12, for H 6.33, for I 5, for J 8, and 9.16. It's usually really difficult to work with this decimal numbers. Now you can go ahead and change this anyhow you want. I just rounded up or down depending on 0.5 and above. I rounded it up, and below that I rounded it down again. I won't penalize you for doing one way or the other. I would like it if you use an Excel and use these numbers and write with the formulas. Doesn't really matter. So what I did was 5.33, I rounded it down to make it 5. 7.16, I rounded to 7. Again, in grading I did not, I didn't penalize you for one. Again, I understand the argument for both sides, so it doesn't really matter. 3.5 is 4, 6.5 is 7, 9.5 is 10, 12, 6, 5, 8, and 9. Well, using these numbers, now we are going to make the project network diagrams. Alright, before that we have to first make the network diagram itself, and then we would fill in with the expected values. Alright, let me do that. Again, we can go to the CMS node we are working on. Alright, let's first make the project network. Again, I've always struggled when working with all these numbers, so let's see. I have the question here on the paper. Alright. Again, it's nice to make the start. Let's call it the start node. There are two here. A, B. To shortcode, I make it this way. It really does. If I want you to practice with this 9 box squares, I'm going to use the shortcut here. For C is A and B. This is C. This is D. Now E has C and D. E has C and D. And then F, Z, D, and then we got coming out of C, and then we have F and G go to H, and then we have I, and then we have G and I going to J, and then we have K, and then we are done. Alright, hoping I made everything correct here. Let's check this. As K has one predecessor, that's J, J has two predecessors, G and I has one predecessor, H has two predecessors, F and G, and G has three predecessors, C, D, E, F has one predecessor, E has two predecessors, C and D, D has one predecessor, A, C has A and B, and then we're back to start. All right, perfect. Let me put processing times here. Change the color here. Insert black. Let me use blue here. All right. Let me put the processing times. So what we calculated, again, numbers used in my number will be different depending on what we choose to round up or round down. So A is 5, B is 7, C is 11, D is 4, E is 7, F is 10, G is 12, H is 6, I is 5, J is 8, and K is 9. Alright, now the fun begins. Let me change the color here again. Let me do this with dark green. Alright, again, somebody to start, let's start with 0 and 0. Alright, so you can start A at 0, 0 plus 5 is 5. You can start B at 0, 0 plus 7 is 7. Alright, now then we can do C, which you can start at, only at 7, 11 and 7, 18. You can start D at 5, 5 and 4, 9. Okay, now you can start E after C and D is done, so 18, 18 and 7 is 25. After E you can start F, F gets done on, you can start 25, 25 and 10 is 35. Z, you have to wait for C, D and E, so 25, 18 and 9, so it's, you can start it in 25, 25 and 12 is 37. You're going to start this on 37, 37 and 6 is 43. You're going to start here at 43, 43 and 5 is 48. You can start this on 48, 48 and 8 is 56. 50, you can start this on 56, 56 and 9 is 65. Again, your and my number might be different depending on if you rounded it or rounded up down. Alright, now you can just bring this number here, 65, let me use a different color here. Let me use a different color, let me use red here. Alright, the earliest, the latest finish is 65, the latest start is 65 minus 9 is 56. Alright, it just has one successor, you can just choose its latest start. 56 minus 8 is 48. Alright, I only has one successor, so you can just bring this 48 here. 48 minus 5 is 43. H has only one successor, so 43, 43, 37. Z has two successors, H and J, so you choose the minimum, that is 43, 37. You choose the minimum here, 37 or 48. Minimum is 37, 37 minus 12 is 25. F has only one successor, so 37, 37 minus 10 is 27. E has 2, 27 versus 25, so you choose the smaller one, 25, 25 5 minus 7 is 18. C has only one success. C has two successors, so you have to choose between 18 and 25. D has two successors. You have to choose between 18 and 25. So you choose the minimum one. 18 minus 4 is 14. Alright, C has two successors. C has two successors, E and Z, and you take the minimum, that is 18. 18 minus 11 is 7. Okay, now B has only one successor, so you just take this 7 here, this is 0. A has two successors, 7 and 14, you have to take 7, so 2. Alright, after you've done that, you can calculate the slacks. Use a different color again. Will be brown here. Alright, 7 minus 2 is 2. 18 minus 9 is 9. 7 minus 7 is 0. 18 minus 18 is 0. 25 minus 25 is 0. 37, this is 2. 37, 0. 43, 0. 48, 0. 56, 0. 65, 0. Alright, that means my critical path equals to B, right, that's the one with the 0, B, C, after that E, B, C, E, G, H, I, J, K. Alright, B, C, E, G, H, I, J, K. My project completion time is 65, but again your number and my number could be different if we rounded it up differently. Alright, now let's go back to our last problem. Our last problem says, again our last problem is very similar to this one, except there is an added question. Again, I made it a little simpler, and let me tell you a trick here which might be handy on this. Again, we want to find the expected value. Actually, in this case, we want to find the variance too. To find the expected value, get the same, A plus 4m plus b divided by 6. For the first part of for the first question, for the first A activity, it's comes out to be 2, because 1 plus 1.5 times 4 plus 5 equals to divided by 6. So 1 plus 6 plus 5, that is 12. 12 divided by 6 is 2. Alright, the most of the values in this question is there's a trick you can use. Given that this m is the midpoint of 1 and 3, this value is just going to be 2. So 3 is the midpoint of 5 and 1, so it's 3. 4 is the midpoint of 3 and 5, it's 4. 3 is the midpoint of 4 and 2, so 3. 5 is the midpoint of 7 and 3, so 5. 5 is the midpoint of 6 and 4, 5. 8 is the midpoint of 8 and 7 is the midpoint of 8 and 6, so 7. 4 is the midpoint of 6 and 2, so 4. 6 is not the midpoint of 5 and 8, so it comes out to be 6.16. 2 is the midpoint of 3 and 2, so 2. 5 is the midpoint of 7 and 3, so 5. I made this calculation a little bit easier. Again, you can do the variance similarly. The formula for variance is b minus a squared divided by 36. So in the first case, it would be b is 5 minus 1 squared divided by 36. So this is 4 squared is 16. 16 divided by 36 comes out to be 0.44. If you do this, you'll get the first one is 0.44. Second one is 0.11, because 3 minus 1 is 2. 2 squared is 4. 4 divided by 36 is 0.11. Alright, so similarly, this is 0.44, D is 0.11, E is 0.11, F is 0.44, G is 0.11, H is 0.11, I is 0.44, J is 0.25, K is 0.11, L is 0.44. Alright, now we can again go to the same S note and make a project network for this problem. Alright, to make a project network, again, I start with a start. Again, you don't have to. I like doing it because for a more complex problem where there are settings with multiple problems, multiple activities with not having a predecessor, this becomes a little easier. Alright, A is the only one without a predecessor. Now B's predecessor is A, C has two predecessors, A and B. D has predecessor B, C, E has C and D. Now we have F, we have Z, we have H, all coming out of E. Then we have I that has H and Z. Well, I guess H also gets from F. And then we have K that gets from I. We have J that gets from I. We have, well, K here, L, and then we have finish. Alright, let's put the activities there. Again, I did the same rounding down for less than 0.5 and rounding up for more than 0.5. Let me use a different color. Alright, blue looks like a right color. Alright, for A we have processing time equals to 2. For B we have 2, C we have 3, D we have 4, E we have 3, F we have 5, Z we have 5, H we have 7, I we have 4, K is 2, J is 6, L is 5. Alright, let's do the forward pass, in which we do earliest start and earliest finish. Let's use color black for this. Alright, 0, 0, so A can start at 0, 0 and 2 is 2, I can start B at 2, 2 and 2, 4, I can start C at 4, 4 and 3, 7, D I can start at 4, 4 and 4, 8, E I can start at 8, 8 and 3, 11, H I can start at 11, 11 and 7, 8, I can't, that's not true. Alright, I can't start H at 11, I have to do F first. F at 11, G I can start at 11, 11 and 5 is 16, F 11 and 5 is 16, H I can start, H has two predecessors, F and E, so F finishes at 16, so I have to wait till 16. Alright, 16 and 7 is 23, I has two predecessors, G and H, so I have to wait till 23 to start. 23 and 4 is 27, K I can't start, so J I can start after 27, 27 and 6 is 33, K I can start on 33, 33 and 2 is 35, L I can start on 35, 35 and 5 is 40. Okay, so we can just do 40 and 40 and 40 and 40. Alright, now we can do the backward pass. To do the backward pass, let me change the color here, we'll give it some color here, let's use red. Alright, 40 minus 5 is 35, so K has only one successor, so I can just bring 35. 35 and 2 is 33. Alright, J has only one successor, so you can do 33. 33 minus 6 is 27. I has two successors, J and K, so I have to do this at 27. 27 minus 4 is 23. G has no, we forgot to make a line here, didn't we? We forgot to make this line here, G going to H. Okay, would that would have hurt us? Would that have made a difference in our forward pass? No, because 16 and 16. I apologize for that. All right, so G has two predecessors, H and I. So 23 and 6. We gotta do H first. All right, do H. H has only one successor, so 23 and 23 and 7. Again, most of the times if you miss one arrow, you probably have to do the all forward pass. Here I know it's not going to make a difference because this 16 and this 16 are same numbers. So alright, now we can do G. G has two successors, H and I. Smaller number is 16, so I bring 16. 16 minus G is 11. F has only one successor, so we can just bring this 16 here. 16 minus 5 is 11. Alright, E has three successors, F, G, H, so 11, 11, 16, so 11. 11 minus 3 is 8. D has one successor, so I can just bring the 8. 8 minus 4 is 4. C has one successor, E, so 8. 8 minus 3 is 5. B has two successors, D and C. So you take the minimum, so 4 and 4 is 4. 4 minus 2 is 2. It has A has two successors, so the minimum of 2 and 5 is 2. So this is 0. Alright, I think we finally got that. Alright, to get the slacks, this was a little complex one here. Alright, 0 slack, 0 slack, 1 slack, 0 slack, 0 slack, 0 slack, 0 slack, 0 slack, 0, 0, 0. So only one has a slack, so this is not a part of critical path. All others are. But if you look closely, all of them are not part of one critical path. Actually, there are two critical paths. The first critical path is A, B, D, E, F, H, I, J, K, and L. The next one is A, B, D, E, Z, H, I, J, K, L. So the only difference is here, F and G. Okay. So the idea which one to use, again, there are lots of thoughts among the scholars on how to use this to find the to use the PERTs, do the PERT calculation. I suggest, again, both of them have the 40, so that otherwise both of them would not be critical path. So obviously we can't use that. So the idea is to find whichever has the higher variance, whichever path has the higher variance, use that. Use the higher of the variances. So if all the values are exactly the same, so only F and G are the only thing to check at. If you look at the numbers, the variance values for F is 0.44. F has 0.44, whereas G has 0.11. So if you take this critical path instead of this, we'll have the higher variance. Again, even if you use the both, you'll get the same answer anyway. But you can't just make a supersized path with A, B, D, E, F, G, H, because that's not true. One path at a time, right? You would have to do the calculation one path at a time and report the maximum answer anyway. All right. So we know the path length, the average completion time for the path is 40 weeks. Again, this answer might be different depending on how you rounded it up. We don't know the standard deviation of this path. But what we want to do, we don't know the standard deviation is what. But we know there is a standard normal with mean equals to mean equals to 0 and standard deviation equals to 1. Okay, we're going to find the probability for 50. Okay, how do we come up with this number? Well, the idea is we know the variances of all the activities in the critical path, so you can find the variance of the path. If I add all the ones, I would get 2.56. Again, this might be different for rounding, if you're rounding up, if you have rounded up or rounded down or anything like that. And its square root of 2.56 equals to 1.6. Okay, so this is, and again, if you had taken the other path, the path with the G, this value would have been smaller. Again, the idea is to take the maximum one. The bigger the standard deviation, you'd penalize the calculations more. That's why we take the maximum one. Alright, we have the standard deviation of 1.6. Now after this, the calculation is pretty straightforward from your basic stats class. Change the color here, red. Alright, so now you want to find what percentage is left of this 50. Well, the trick is to find the equivalent of this in the standard normal. That's what the G calculation really is. So G, let's call this G. G is 50 minus 40 divided by standard deviation of 1.6. Again, this is roughly 1.6. Comes out to be a pretty high number, 6.25. Now we know when the G is that high a value, the probability associated with this G, if you look at the standard normal table, you'll see it's 100%. So the probability that the project will be done by 50 days is 100%.